Hey, welcome back to Math with Patrick. Today is February 27th, and we have problem number 58 to solve from this Daily Epsilon calendar. We need to find how many digits there are in 20 to the power of 20. Well, one thing we could do, it'd be a little silly, is to multiply out all of these 20s. There would be, 20 of them, because that's just the meaning of exponentiation, or raising something to the power of 20 will mean that I have 20 of them. So I could just figure out what this number is, but it seems like it's going to be obnoxiously large. I'd rather think through this a little bit more smartly, I guess. And here's what I'm thinking. So 20 to the power of 20 is going to be the same as 2 times 10 to the power of 20. I'm just factoring 20 there. And if I have 2 times 10 multiplied to itself 20 times, that's essentially 2 times 10 times 2 times 10 times 2 times 10, 20 times over. And I could reorganize it if I wanted to, or I have 2 to the 20th, then times 10 to the 20th, because you can do multiplication in any order you want. And I like it this way because counting my powers of 10 will be pretty easy, especially when I want to know how many digits there are. So if we take a little look-see at the tens real quick, if I have 10 to the power of 1, my exponent is 1, and the number of digits I have is 2, because there's 1 and then 0. If I do 10 squared, that's going to be 100, and I have 3 digits. 10 cubed is 1,000. I have 4 digits. And so it looks like I have the same amount, or I have one more digit than I have exponent. Another way to think about it is that I have the same amount of trailing zeros as I have my exponent here. So, 10 to the power of 1 is still 10. 10 squared is 100. I have 2 trailing zeros. And then 10 cubed is 1,000, and I have 3 trailing zeros. And I think I actually like it that way better because that shows me that 10 to the power of 20, all this does is it takes the number you have and then give it some amount of trailing zeros. So 10 to the power of 20, like say times 2, is going to be 2 with 20 zeros following it. So 10 to the power of 20 itself is 1 with 20 zeros at the end. But if I multiply anything else next to it, which we will in 2 seconds with this 2 to the power of 20, it'll be whatever I have with 20 zeros at the end. So I am really confident that this part here is going to impart 20 digits to my overall number, and all of those digits are going to be 0. So 20 trailing zeros. Now we got to figure out how big 2 to the power of 20 is. Well, surely it's not as big as 10 to the power of 20, so this thing shouldn't have 20 digits all on itself, or in itself. And I'm trying to think if there's a clever way to figure out how many digits I have here, besides just trying to compute the number. Like, it won't take me that long to figure out what 2 to the power of 20 is. I've done my powers of 2 a whole bunch. And you can just kind of keep doubling the number and then see how far you can get, just kind of with like your intuition of doubling or adding it to itself. And I'm kind of at an advantage here because, math is my job. So I've done this doubling pretty far. If you've also played the game 2048, it was like all the rage like a few years ago. It's all about counting by your powers of 2. And I can keep going. I can double 2048. Here's where it gets a little bit dicey. How many 2s do I have so far? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hold on. Well, actually, let me cut it off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 at 2 to the power of 10. I know that 2 to the power of 20 is just, 22s all multiplied to each other. It's also going to be the same thing as 2 to the power of 10 times 2 to the power of 10. And at this point, I think it might be easiest to just do some long multiplication and figure out about how big this number is going to be. And I mean, I can already tell that it's around 1,000 times 1,000, and it doesn't seem like it's going to be much bigger than that. And so if I'm going to be counting up digits, it might be nice to just round 2 to the power of 10 to about 1,000. I'll prove it afterwards that rounding it is okay, but there shouldn't be any way that 1,024 times itself will somehow give me one more extra digit than 1,000 times itself. So 1,000 times itself, you can just kind of count up the amount of zeros you have. And so that's going to be 1 with 6 trailing zeros. And then since I'm also multiplying it by 10 to the power of 20, that gives me 20 more zeros here. So 20 more. And so I can just kind of count up that I have 20 digits here. They're all zeros. 21, 22, 23, 24, 25, 26, 27. And so here, I am really confident that 20 to the power of 20 has 27 digits. It is also today's date, so I know I have the right answer. But just to make sure, let me actually do that multiplication for 2 to the power of 10 times 2 to the power of 10. And I might actually need a bit more space, so let me do that over here. So just running through that multiplication algorithm, 4 times 4 is 16, 4 times 2 is 8, plus the 1 is a 9, times 0 is nothing, and then 4 times 1 is 4. I need to put a placeholder of 0 and then double this whole number. So I have 8402. Placeholder 0 for this guy. I will have nothing in this hundreds place, so I'll skip over it. And then 3 placeholder zeros for my 1,000, and that's just going to be the same number, 1,024. And then so adding up all my digits, I have a 6 in the ones place. This is a 17, carrying the 1 gives me a 5 in my hundreds place. 8, 4, 0, 1. And so like I was thinking, 2 to the power of 10, which is 1,024, multiplied to itself is going to be pretty close to just a million. And I can just edit these numbers, actually put in the real value here, and I didn't give myself another digit. So I have proven that 2 to the power of 20 gives you 7 digits. And then I know that the 10 to the power of 20 part of it will give us 20 more digits. All of those are going to be zeros. So we have our 27 digits. I guess I'll rename this part here to say that I have not 20 more, but 20 zeros, because I didn't really have any repeating zeros until this one right here. So 20 zeros at the end. We have 27 digits overall. And we're all done. Well, thanks for coming along. Hope you enjoyed, and I'll see you tomorrow. All right.